Okay, welcome to this video where we're going to be having a look at the remaining topics on the higher revision checklist. Now you'll hopefully already know that we've already done 3 videos covering the majority of the topics across the checklist, and this is the video that's going to finish it off to make sure that we have a full coverage of a practice question on absolutely everything. Now there are a couple of topics that there have been a little few exceptions for. I've not included a trigonometric proof question, so you may want to have a look at those, or they are very rare that they come up and they're all very unique questions. As well as that, I've not put in any constructions and loci just because it's a bit of a rubbishy one to be doing on the screen, but there is a video that I have made on it and I will link that in the description if you do want to check out any constructions and loci. The only other one I didn't put in was a conversion graph, and that's just because they don't tend to come up a huge amount, and I did put in a lot of conversions with units and also with currency and best value. So there was a really good question that I included rather than putting in a conversion graph. But other than that, we have now covered absolutely everything on the GCSE. Now, as with all of these, you do need to make sure you check all of those videos in the description, because there are 3 papers already for you to look over to make sure that you've covered everything, but there are some fantastic questions included in this video that I think you're going to really enjoy. Now, with all that being said, let's start the video, but very quickly before we get into it, I'm just going to show you the new TGMT Upgrade programme. If you're only going to watch one video this year, this is the one. With GCSE Maths right around the corner, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1, head to the TGMT hub, go to the bottom of the page once you've logged in and access the revision quiz. From here you can answer a question on every topic within the GCSE. You can go through working through each question and making sure that you practice absolutely everything. Once you've done that, you are going to get a full report that shows you exactly what you got right and wrong on all of these questions. So work your way through the quiz and then access your report. From here you can see on individual units what you need to work on and what you've already secured. So identify what you need to work on. Then we're on to step 2. Head back to the hub. You can go through the units, you can go to the exact one that you know that you need to work on, and you can access all the individual topics within that unit. Once you've done that, you can pick the topics that you want to work on, watch the video, and you can complete a topic quiz for that particular topic. So work your way through the quiz, answer those questions, and then you're going to get another report. That's going to show you exactly what you got right and wrong, so that you know if you need to do any more work. Step 3, head back to the hub and go to the bottom. You can now go onto the upgrade quiz. On here, you're going to be able to answer questions again, different to the first, on every single topic within the GCSE. Once you've done that, you're going to get another quiz breakdown on the report that shows you exactly what you got right and wrong, so you can put any of those finishing touches in before that exam comes along. With the exams right around the corner, we need to make sure that we make revision simple. Join Upgrade. Okay, there we go. So make sure you get yourself signed up to do the free trial. Let me know what you think, drop me a comment, but let's get started with the video. So obviously we're looking at the higher tier paper, and like always you can scan the QR code here at any point to come back to the video if you have the booklet printed off and in front of you. So question 1 here, we are multiplying decimals. So obviously non-calculator, but some of the questions as we go are going to be calculator, as this is just kind of a mishmash of a lot of different topics and some really good ones that we weren't able to include on the previous ones. So unless I say otherwise, they are a non-calculator question, or could appear on a non-calculator paper at least. So take those decimals out and we'll do 546, and we're going to multiply that by 43. Whatever method of multiplication you want to use is fine. 3 times 6 is 18, 3 times 4 is 12, plus the 1 is 13, 3 times 5 is 15, plus the 1 is 16. Placeholder for the 40, 4 times 6 is 24, 4 times 4 is 16, plus the 2 is 18, and then 4 times 5 is 20, so 21 at the end, and then we just need to add that all together. So 8, 7, that's 14, 3, and 2. So 2, 3, 4, 7, 8. We took 2 decimals out at the start, so we're going to put 2 decimals back in, and our decimal point is going to go just there. So writing that nice and neat on our dotted line, 234.78. And on to question 2. So this sort of question here, straight away when you look at it, you know it's going to be a two-way table or a frequency tree. So I always like to go for a two-way table, and let's just see what things we've got. We've got 100 adults were asked whether they go to the gym, run or cycle. So we're going to need 3 for that and a total column at the end. So let's go with gym, run and cycle in the order that it's written, and then we've got a total. And then we've got, let's have a look, males, females, and then a total. There we go. So males, females, total. And the question is saying, how many females run? So let's have a look. We're looking for this box here, and we just need to fill everything in from the question. So we've got 100 adults were asked in total, 45 of them were females, so straight away we can say 55 are male. Tick these off as you go. 30 of the 52 adults who go to the gym are female, so 30 out of 52 are female, so straight away 22 are male. 35 adults run, so that's the total down here, and then 9 males cycle. So then all you have to do is go through the different columns and rows, finding anything that you can fill in. So on the top row we can find out the amount of males that run, because we have the total is 55 and at the moment there's 22 and there is 9. Add them together is 31 and take that away from 55 would give you 24. Now we don't actually need to go and complete the rest of this two-way table because we now know they add up to 35, so this must be 11. Although if you were to go through and complete it, this would be 4, and then adding those together would give you 13 down here. But our answer for this question is 11, and we got there relatively quickly, so there we go, our answer would be 11. Okay, on to the next one. So for this question here, we have some information about the heights of some Year 8 girls, and it says the least height, the median height, and the greatest height. Then we also have a stem and leaf that shows some information about the heights of a group of 15 Year 10 boys. And it wants us to compare the distributions. Now when we're comparing the distributions, we're just going to look at any of the different averages that we can find. Now in the table, we're given the median, so straight away we should find the median from the stem and leaf. Now if there are 15 students, you can either cross off either side and find the middle, or you can take more of a statistical approach, which I'm going to do. So feel free to do that if you want, but to find where the middle is, add 1 to the total. So 15 plus 1 is 16, and then just divide that by 2, and it will tell you where the middle person is, or the 8th person along. So 1, 2, 3, 4, 5, 6, 7, 8. So it's that 8th person along, get rid of these ones, that is the median. So look at the key, that's representing 158 centimetres if it's 15-8, so 16/8 will be 168 centimetres. Now the Year 8 girls, the median was 165. So I just want to write this down. I do want to mention the context of the question. It is about the heights. It says to talk about the heights. So I would say the median height for the boys is higher than the median height for the girls. There we go. And mentioning that word height, the median height for the boys is greater than the girls. There we go. The next thing that I can find, and the only thing I can find because of the information I've been given up here, is I can find the range. So the range is the distance between the biggest and smallest. So to work it out for the girls, 170 take away 150 would give me a range of 20 centimetres. To work out the range from the stem and leaf, I just need to be careful, obviously, as we read from the key properly. We've got 182 here as our largest, so 182 and 158. So minus 158, make sure we get that correct, that's 24. So there we go, 24 centimetres. So the range for the girls is 20 centimetres and the range for the boys is 24 centimetres. So I could also say the range of heights, let's make sure we get it right for the boys, is also greater than the girls. And there we go. There is our little written comparison of the distributions. Okay, so on to our next question. So for this one, we are drawing a plan of the solid. So a plan is from above. So from above, you can see that we have 3 squares here. To the right of that, we have another 2. And then we also have 1 on the very end of that. So there are 3 on the bottom. Let's have a look. I've also then got 2 on top of that, just here. And then 1 on top of that. There we go. So if I draw in all of those horizontal lines as well, that's what it would look like from above. You also have a change of height on this top cube on its own. So you draw a slightly thicker line just in there, just to represent that little change of depth or change in height. And there we go, that is drawing a plan. For our next question, we have some bearings. So this one here, we are given a diagram. Now the diagram, let's have a look, shows us an angle of 50, it gives us the 3 north lines and points A, B and C. It says the bearing of B from A is 070. But that's not drawn on the diagram. So to get to B from A, that means we're at A and we're turning this amount of degrees here to get to the direction to go to B. And in just terms of an angle rather than a bearing, that is 70 degrees. It says angle ABF is 50 and AB is the same length as CB, meaning this triangle here is an isosceles. Work out the bearing of C from A. So to get to C from A, let's write this in a different colour, that'd be this whole angle just here. Now we already know that part of that is 70, so we just need to find the missing angles in the triangle. As it's an isosceles, and 50 there is our top angle in that isosceles, we know that the base angles are equal in an isosceles. So if we take away the top angle from 180, we get 130, and divide that by 2, that gives us 65 degrees. So we know that both these base angles are 65, which would be this angle here, and also the total of this angle here. Obviously we're looking at the bearing of C from A. So to get to C from A facing north, you would have to turn 70 plus an additional 65. So our final answer would be 70 plus the 65, and that would be 135 degrees, and that is already a 3-digit bearing, so we don't have to worry about adding a 0 at the start or anything, as it's already 3 digits. So there we go, 135 degrees, and there is our bearings question. On to question 6. Now this is a calculator question, but it's not a calculator topic. It could come up as a non-calculator version as well, but here is a calculator version. So it says there are 20 men, 10 women and 10 children. The mean score for the women is 15.6 and the mean score for the children is 9.2. Jennifer says that the mean score for all 40 is 11.2. Work out the mean score for the men. Now in order to do this, we just need to multiply what we've been given by the amount, or the mean by the amount. And to be fair, me saying it is a calculator question, this could actually be done non-calculator as well. But normally when there are decimal means in there, it normally is a calculator question. But I've just spotted it's only 10, 10 and 20 there, which are quite nice to do without a calculator. And in fact, this I'm going to use a non-calculator approach. So the mean score for the women is 15.6 and there are 10 women. Now again, you can write some form of algebraic equation for this. The total, we don't know, divided by 10 women would have to equal 15.6, and to solve that you'd times by 10. But I just link together the amount with the mean, multiply them, and I tend to find that that's a little bit easier. So 15.6 multiplied by 10 would give us 156, and that is the total for the women. For the children, there are 10 children and the mean is 9.2. So 9.2 times 10 would be 92, and that would be the total for the children. The mean score for all 40 people is 11.2. So we can do that again as well. We can do 11.2, the mean, multiplied by the 40 people. That's not quite as quick to work out, but we can either times it by 4 and then times it by 10, or times it by 10 and then times it by 4. Either way, so if I times it by 10 to start with, 11.2 times 10, that is 112, and then 112 times 4, and that would be 448. There we go. So the total for the whole Is it the whole class or all the people in the competition? That would be 448. Now, to be fair, it does start to feel a little bit more like a calculator question, but this could be non-calculator, so we'll stick with it. So work out the mean score for the men. Well, there are 20 men. So whatever the total is for the men, we're going to divide it by 20. So to find the total for the men, we can take the 448 and subtract the women and the children. That's up to you. I'd probably add those two together first. So 156 and 92. And if we add those up, let's have a look. What do we get? 248. That's a really nice one to subtract. Yeah, it's definitely non-calculator look, because that's a really nice one to subtract. In fact, we don't even really need to do column addition for that, do we? But we'll write it anyway. 8 take away 8, 4 take away 4, and 4 take away 2. So the total for the men is 200. It's always worth sort of labelling this total for the men. And then there's 20 men. So to find the mean, we would divide that by how many there are. There are 20 men. So 200 divided by 20, and that gives us a really nice answer of 10. So the mean for the men is just 10. There you go. So not actually too bad. Looks a lot worse than it is when you first see it. I think I'd have definitely thought that that was a calculator question when I was if I was doing a non-calculator before I started actually answering it and realised he got quite nice numbers. So Jennifer was wrong. The mean score for all 40 people was actually 11.15. How does this affect the mean score for the men? Well, if 11.15 was their actual mean, that means when we did this calculation here, 11.2 times 40, we'd have actually done 11.15 times 40. And 11.15 multiplied by 40, if we'd have done that instead, we won't work that out, 11.5 times 40, the answer will be less than 448. Okay, I'll write that as an inequality. You don't have to write this, but that is less than 448. Now that means that the total for the men would be less, because we'd still take away 248, the total of the women and children. But that would mean we would do a smaller number divided by 20, and therefore the men's mean would be smaller. So we would say the mean would be less, or any variation of this language, the mean would be less. There we go, as the men's total would be less. There we go, the men's total would be less. There we go, and that would be a fine explanation or any variation of that language. So there we go, there is some reverse mean. Question 7, we have a probability tree. Now this tree is already filled in, so let's have a look. A biased dice is thrown. We've got the first and second throw. Write down two things that are wrong with the probability tree, or the probability diagram. Okay, let's have a look. So the first thing that I've just noticed, I noticed this one relatively quickly, 0.65 and 0.25 do not add up to 1. That adds up to 0.9, and we know that on branches, the branches have to add up to 1. So to start with, I would just say, and what have they called that? The first throw. There we go, so the first throw adds up to 0.9. And we could say it should be 1. Or it should add up to 1. And again, if you're not sure how to describe it, you can always point it up to here to show exactly which piece you're talking about, which part of the question you're talking about. Okay, so looking at the next part of the tree, the second throw, again, look, these have been switched. So that is 0.35 on lands on a 4, and then it's switched to 0.65, and they should be the same. So we would say on the second throw, there we go, the second throw, the probabilities have been swapped. There we go, the probabilities have been swapped. There you go. You could add more information to this, like we could have said that 0.25 should be 0.35. We could say things like lands on a 4 is 0.35 here, and it should be 0.35 here. You could really write as much as you want, but just make sure it's really clear what you're talking about, and you can always draw arrows to represent or to show what the actual statement that you're making represents. So there we go, there is some probability trees. Here we've got some angles in a polygon. So it says here ABCDEFG is a regular octagon, ADJ is a straight line, BAD equals CDA, which we can see all on the diagram. Show that angle CDJ is 135. So this angle here is the one that they want us to show is 135. But it says show that it's 135. So let's just imagine that we don't know what it is. We're going to find what that is. Now straight away, as soon as you see the words regular octagon, straight away I would be working out the interior angle. So there's a formula that we do 8 take away 2, the amount of sides take away 2, multiply that by 180 and divide by how many sides it has, or how many angles it has, which is 8. 8 take away 2 is 6, so that's 6 times 180, all divided by 8. 6 times 180, which if you have a calculator you can type it in, if not you need to do some column multiplication. That adds up to, or multiplies together to make 1080 divided by 8, and then you can do bus stop to work that out as well, or if you have a calculator you can just type it in, but this honestly this question could be on either paper. So 8 goes into 10 once, remainder 2, goes into 28 3 times, remainder 4, and it goes into 45 times. So the interior angle in an octagon, a regular octagon, is 135. Now I can label that on most of these. We're obviously concerned about moving to the top of the shape, but some of those angles have been split in half. So I can only really label it on those ones, as this one here has been split and so is this one here. You could write it there if you want though. Now the thing that I'm spotting here is this is a trapezium. Now we know that angles in a quadrilateral add up to 360. So we know that to get these two base angles, which is told us are the same, we'd have to do 360, take away the total of the two top angles, and they both add up to 270. So if you do that, you end up with 90 degrees left over. We know that both those angles are equal, so we can divide it by 2, and that gives us 45 degrees for each of those kind of base angles in this shape, if we imagine it's they're the base. So there we go, there are the angles in that particular shape, and it's now told us as well that this is a straight line. We know that angles on a straight line add up to 180, and the 45 with the angle we're looking for creates a nice straight line there. So to find that final missing angle, which I've called X, which we'll write down here, we would do 180 take away this 45, and 180 take away 45 is equal to 135 degrees, and there is what it wanted us to show. Now you could write that as angle CDJ, you could put in your actual angle language, however you like to write that, if you like to write it in a nice ordered list, or you can just sort of label it around the diagram. You just need to make sure it's nice and clear though. You don't want this dotted all over the place with no sort of logical progression through the question. So there we go, there are some angles in polygons. Okay, so for this question here, definitely a calculator question, so grab your calculator. We are looking at surface area of a cylinder. It says here Maria has to cover 3 tanks completely with paint, and each tank is in the shape of a cylinder, with a top and a bottom, and the tank has a diameter of 1.6 and a height of 1.8. Now whenever I see a shape like this with circles, I always like to write both. So I'm going to write the radius in as well, which is half of 1.6, which is 0.8. Maria has 7 tins of paint, and each tin of paint covers 5 meters squared. Well, straight away, before I even move on, that straight away tells me she's got 7 lots of 5, which is 35 meters squared. So the whole point of this question, are we going to be under or over 35 meters squared? So has she got enough to cover the 3 tanks? And you must show how you get your answer. Now when you are working out the surface area of a cylinder, you have 2 circles. So straight away I would do pi r squared and write this down. That's our area of a circle. So working that out, that would be pi times 0.8 squared. And we just need to type that into the calculator. So let's type that in. So pi times 0.8 squared, and that comes out as 2.0106. There are some more decimals there, but I don't think we're going to have to go into that far, as we are just comparing it to 35. We're not working out the exact surface area to a certain amount of significant figures or anything, so that would be fine. Now there are 2 circles, so I do need to remember to double that. I may as well do that now, otherwise I'll probably forget later. Let's times it by 2. So the total area of the 2 circles is 4.0212. There we go, I'll put a metre squared with that. Just reminds me that that was a final area that I was working out. Now for the area of the curved surface going around the cylinder, that has a kind of shape that looks a little bit like, well, like that. There we go. It's definitely a rectangle, but it's kind of hard to visualize it because it's wrapped all the way around that cylinder. Now we know it has a height of 1.8, that's given to us on the diagram. But the difficult part on the cylinder, and the bit that people tend to forget, is that the length or the width, however you look at that rectangle, of the rectangle is the circumference of the circle. And circumference is equal to pi times the diameter, or pi d, or you could also have 2 pi r. Any of those are absolutely fine. So if we go about working that out, the diameter was 1.6. So for this length here, we'd do pi multiplied by 1.6. And if we type that in, pi times 1.6, we get 5.0265. So the length of that, or the width, however we kind of look at it, I'll call it the base, that's a bit easier, 5.0265. Again, there are some more decimals after that, but as I said, we're only comparing it to the other one. So area of a rectangle, nice and easy, we just need to do the length times the width, or the height times the base, 1.8 times 5.0265. And let's just times that by 1.8 on the calculator, and we get an area of 9.0477 and some more decimals. It's an 8 after the 7, so technically we should round it, but it's fine to leave it like this for the context of this question. And there we go. So if we add those two together, so 4.0212, add 9.0477, now I'm not actually going to do column addition here, just a way of writing out my working. I just need to add the 4.0212 on the calculator, and I get my final area or surface area of one cylinder as 13.0698. Now it said in the question that we have 3 tanks, okay, so we have 3 of these. So I just need to multiply that by 3. That's going to tell me the overall surface area of the 3 tanks. So just press times 3 on my calculator, and that comes out as 39.2069 meters squared. Now look, the important part here, and why I was happy to just round them as I did earlier in the question, look, that's well over 35, okay? So we are nowhere near able to cover them. So when we write our description here, we would say no, okay? And you could say something along the lines of 35 meters squared is less than 39.2069. I can write that using an inequality as well. So 35 meters squared is less than 39.2069 meters squared. You can write that in words as well as you want, if you want, but I quite like to use the inequality as I'm going along. So there we go. There is our final answer. No, she does not, as she has less than 39. Now onto a pie chart question. Now as with any pie chart question, it's a bit of an awkward one to do on a video, but I wanted to make sure it was still included. And this was a really good question. What I'm not going to do is I'm not going to get the protractor out. I'm just going to kind of tell you how to approach it, and we'll sort of go through this question together. But obviously you can have a go at this one if you've got it printed as well. So it says the pie charts give information about the ages in years of people living in 2 towns, Adley and Bridford. We've got the pie chart showing that. It says the ratio of the number of people living in Adley to the number of people living in Bridford is given by the ratio of the areas of the pie charts. What proportion of the total number of people living in these 2 towns live in Adley and are aged 0 to 19? Now straight away we're looking at Adley. So what proportion is 0 to 19 in Adley? And that's this one here. Now if you put your protractor on there, I've measured it out, I've got it printed off, that one measures out as 70 degrees. So in terms of proportion, that is going to be 70 out of the 360 degrees in that circle. The only other thing that we need to find out is what proportion is Adley in comparison to the whole population. So we know that's the fraction of the amount that we need to work out. We just need to think about what the actual proportion of the population is now as well. So if we actually think about how we would do this, it says that the ratio of the number of people living in Adley to the number of people in Bridford is given by the ratio of the areas of the pie charts. So you actually have to get your ruler out and measure the radius, which is quite a unique style for a pie chart question. Now, depending on what size paper this is printing off, what the margins are, all sorts, this is going to kind of change. So you're going to have to kind of create yours, maybe might be slightly differently to mine. But when I measure this out, this one here comes out as 5 centimeters, and this one here comes out as 4 centimeters. So when we actually work this out, to get the area of those two pie charts, let's have a look. So this one here, we've already done area of a circle in this video. We do pi times 5 squared. And this one here, I'd do pi times 4 squared. Now I could write that in terms of pi, but given that if you've got this printed, it might come out slightly differently. I'm going to write out the whole numbers. So I'm going to do pi times 5 squared, and instead of writing 25 pi, which I would actually do in this situation, I'm just going to write the actual area. So 78.5398. Let's see how many significant figures I can get away with. It says it wants the answer to 3 significant figures. I've written 1, 2, 3, 4, 5, 6, so that's going to be fine. Would be fine to leave all of the numbers in, ideally. I'm going to save a little bit of time. So pi times 4 squared for the other one, and that comes out as 50.2654. It's an 8 afterwards, so we should round that to a 5, but it's going to be absolutely fine to that. 6 significant figures. So there we go. That is the area of the two circles, and we know that that's in a ratio. Now, as a bit of proportion, the area of the Adley pie chart, 78.5398, is out of the total area of the two pie charts. So these two added together, what would they be? Well, let's add them together on the calculator. So plus 78.5398. That would have been a lot easier in terms of pi, because this here would have been 25 pi. This here would have been 16 pi. And then we could just do 25 pi out of, what would that be, 41 pi. So that would have been a little bit nicer to write down, but we can do it using numbers still. They add up to make 128.8052 if I give it again to 4 decimal places. So that's the number that's going to go on the bottom. It's 78.5398 out of 128.8052. And that's the proportion of people that live in Adley. Obviously more people live in Adley than Bridford. So there we go. So out of that proportion, we know that 70 out of 360 are aged between 0 and 19. So if we actually just want to work this out, we can just write those two and either work out a fraction of this, or the quick way when you're using a calculator is just to times them together. It's similar to if you're working, say, I don't know, 2/3 of, I don't know, a nice easy one, 2/3 of 12. You don't actually have to divide by 3 and times by 2. If you have a calculator, you can just do 12 times 2/3. So I'm just doing the same concept. I've just obviously made those numbers up, but I can just do the same thing. So if I bring these down, there you go, let's bring those down below, and we'll actually, there we go, bring that down here so that we can type those in. So 78.5398 over 128.8052, and just multiply that by the fraction that we're looking at. So we'll give us our answer as a decimal, but that's fine. Let's just type it in. So 78.5398 over the 128 number multiplied by 70 over 360, and that gives me the decimal 0.118563676. I've written all those down because when I multiply that by 100 to turn that into a percentage, which I could do, or I could just leave it as a decimal. To be fair, it would be absolutely fine to leave it as a decimal. So I could round it as a decimal to start with, 0.119 to 3 significant figures, as it's a 5 after the 8. Or I could actually times that by 100 and I could write it as a percentage, and that would be 11.9%. Okay, now again, imagine depending on how you've printed this and everything, that might be ever so slightly different, but you can see the process there of how we did that, and also obviously you can sort of amend your numbers along the way. Okay, so there we go, on to the next one. So Jack bought a new boat for £12,500. The value of V of Jack's boat at the end of n years is given by this formula. We have 12,500 times 0.85 to the power of n. Now straight away, that is a depreciation multiplier. To get that 0.85, that means it's only 85% of its value each year, which would mean, and you kind of think about this, 100 minus 15 gives you the 85%, so it's going down by 15% every year. You wouldn't necessarily need to know that because the question just says, after how many years was the value of Jack's boat first less than 50% of the value of the boat when it was new? Now straight away, if it's going to be 50% of the amount, that's going to be half the value. So if I do 12,500 and divide that by 2, that's going to tell me I need to know when is it going to be £6,250 or less. Okay, it does say first less than. So we don't want to know if it's, if it comes out of 6,280 one year, we'd be looking at the next year. So let's just have a look and just type some numbers in. Now when you're doing this, you just need to guess. So I'll guess one, 12,500 times 0.85. I've got to really try and not just guess it right. I'm going to go with 4. If it's right, it's right. 12,500 times 0.85 to the power of 4. And that comes out as, okay, I'm not right, 6,525 and 7p. There you go. So it's not quite less. It does look like it's going to be 5. So let's just type in 5. There we go, and 5 does go below it. So if I do 12,500 times 0.85 to the power of 5, I get £5,546 and 31 pence. So in terms of how many years, I would say 5. You could write 5 years there, but it does say how many years, so it's okay to write the number 5. So there we go, a little bit of depreciation there, and that's obviously important to know this bit at the top as well, because if the question said it depreciates at 15% per year, you would obviously need to write that formula yourself. So you do need to understand where that formula's come from. Okay, on to our next question. Okay, so this question says, a savings account pays interest at a rate of R% per year. Jack invests 5,500 into the account for 1 year, and at the end of the year, Jack pays tax on the interest at a rate of 40%. After paying tax, he gets £79.20, work out the value of R. This is quite a tricky question, to be fair. Quite nice that it says it's only in there for 1 year. But let's have a look. So in order to do this, we would say, if we think from the start, normally with compound interest and interest, we'd do 5,500 multiplied by whatever the percentage rate is. So as an example, if it was something like 1.5%, you would multiply by 1.015. The problem is we don't know what that is. So let's just call this x at the moment as it's an unknown. And that's going to equal whatever the new amount is. But again, the problem is it doesn't tell us how much he has. What it does tell us is that the interest rate is 40%, and after paying that, he gets £79.20. So what we actually have is a bit of a reverse percentage mixed into this. So what we know is that £79.20 is equal to 60% of what he gets after 40% is taken. So to turn that back into 100%, we would want to break it down. So, I mean, it's up to you. It's a calculator question, so I would divide by 60. You could divide by 6 to get 10%, then times by 10, or any variation of this. I'm going to divide by 60 though. And that comes out as £1.32, which is equal to 1%. We can now multiply that by 100, and we get £132 is equal to 100%. Which means that he was given £132 in interest. So we know that after we multiply by x, he got whatever that new total is. So we probably need to work that out first. So 5,500 plus the 132, he would have £5,632. So whatever multiplier we've used gets us to 5,632. Now to reverse that, we could divide both sides by 5,500 to see what it's been multiplied by. And if we do that, we get x is equal to, and it comes out as 1.024. Now, think back to what we said here. 1.5% is 1.015. So this 2,4 at the end is very similar to that, and a good one that I picked. So looking at those, 1.5 is 1.015. 1.014 is going to be 2.4%. Okay, numbers in this column here will represent like a 10, a 20, a 30%. This is a 1, 2, 3, 4%, and this is a 0%, so 0.1, 0.2, 0.3. So we only have those two, so it's 2 in that column, 0.4 in the final column. So 2.4% was the interest rate that he got. That gave him £132, and he was taxed 40% on that, which is why he only received £79.20. So there we go, 2.4%, and on to our next question. Now, these questions are not very nice. It says in London, 1 litre of petrol is 108.9 pence, and in New York, 1 US gallon of petrol costs $2.83. It says 1 US gallon is 3.785 litres, and a pound is $1.46. In which city is petrol better value for money, London or New York? And you must show your working. Now, straight away, there's a few things that stand out. Number one, they're in different units, so they need to be in the same units. And number two, they're in different currencies. So we have quite a few conversions going on in this question. Now, for starters, I'd much rather this be written in pounds, as my conversion is going to be working in pounds. So I'm going to divide that by 100. It comes out as, I'll write it with a pound symbol, 1.089. So £1, 8 pence and a little bit. So we have got, it's almost £1 and 9 pence. Now the second one is in gallons and in dollars. Now obviously I want to convert it to our home currency. So if we convert it to pounds, which we've got in our exchange rate there, £1 equals, and I want to convert the gallons into litres so that we can make a fair comparison. We're not going to be comparing well, one's in litres and one's in gallons. So it tells us 1 gallon is 3.785 litres. So this here is going to be 3.785 litres. I'll write litres there. And that has a cost of whatever this is in pounds. So to convert from dollars back to pounds, we want to divide by the exchange rate. So 2.83, as the pound number in our exchange rate here is smaller, and divide that by 1.46. Now, when we type that in, we don't get a very nice number at all. It's I'm going to write the whole thing down, 938356164. I'm going to write it all down because normally on these questions the answers are very close to each other, and there's a recurring decimal above the 3 and the 4. So to be honest, if we had this question in the exam, you'd probably be sitting there thinking, surely I've done something wrong, but that can happen. You can get some pretty nasty numbers like that, particularly when we're dividing pence and stuff by an exchange rate. Obviously in real life these numbers are just rounded, so if you were going to exchange that much, you'd just get £1.93, you wouldn't get 1.938 and all those decimals. But we have a fair comparison now. We've got 1 litre costs £1.089 in London, and 3.785 litres costs 1.93, and that horrible number there. Now we want to know the cost of 1 litre, so now we're going on to our best value. And in order to get the cost of 1 litre, you just divide by how many litres there are. So if we divide that by 3.785, that's how we get to that to become 1. Now the thing is, we need to do the same to the price as well. So divide that by 3.785, and that will give us the cost of 1 litre. So 1 litre is going to equal, and when you type that in, you get, and this is not even anywhere near the other one, 0.512115235. Now if I keep that to the same amount of decimal places as the other one, 0.512, and that's now pounds for 1 litre, and that's in New York. Now looking at what we've got, look, the price in London is over £1, but in New York down there it's actually less than £1, almost half of £1. So there we go, we can see that New York is better value. There we go, New York is better value. Now there are quite a few different ways of approaching that question, so you might actually approach that in a completely different way. You could have converted everything into gallons and dollars, and there are kind of other ways that you could approach the movement, but I think that that is the simplest way there, getting the gallons into litres and just converting it all back to one or the other. So I chose to go with litres and pounds, but you could choose to go the other way. But there we go, there is exchange rates mixed in with some unit conversions and best values all in one question. Okay, on to our next one. Now this question here says, the diagram shows a prism placed on a horizontal floor and it gives us the formula pressure is equal to force over area. The prism has a height of 3, which we can see, and the volume of the prism is 18 metre cubed. The pressure on the floor is 75 newtons per metre squared. Work out the force. Now straight away I would want to draw a formula triangle that shows pressure, force and area. So pressure is equal to force divided by area. And if we want to use force, then we would cross the force out and we would do pressure times area. We know the pressure, we've been given that, 75 newtons per metre squared. We just need to multiply that by the area. So we know we're going to be doing 75 times something. The problem is we don't know the area of the cross section, but we have been told the volume. The volume is 18, and we know that to get the volume of any prism, you multiply the area of the cross section and times it by the length it goes through the shape. In this case, that's 3. If we do the reverse of that, to get the area of the cross section, we do the volume divided by the length it goes through the shape, and that tells me the area, which is 6. So the area of this base must be 6 metres squared. So I'll just do 75 and multiply that by 6. And if I do that, that is going to give me the force. 75 times 6 is 450, and that is in newtons, and newtons is already on the dotted line. So there we go, 450 is our final answer. So we had a little bit of reverse area there to get the area, a reverse volume to get the area of the cross section, and then applying that to pressure, force and area. Okay, on to our next question. Here we've got a box plot. It said it shows some information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. It says work out the interquartile range of the information. Now to work out the interquartile range is quite a nice one. We just find the lower quartile, which is right here, although that is right in the middle of a box, so that's a bit of an awkward one. So that number there is 60, as that's between 40 and 80. Which means we need to be really careful with the scale here, because we've got 1, 2, 3, 4, 5 boxes going in between, and that has a little stretch of 20. So actually when I thought this was going to be easy, we've actually got a bit of a pain here with the scale. So if there's 20 in between and there's 5 boxes, each box represents 4. So that would be 44, 48, halfway through would be 2. So actually, yeah, that's bang in the middle, and that's going to be 50. To be fair, I probably should have spotted that a little sooner, that it was right in the middle of 40 and 60. So there we go, 50 is the lower quartile. At least I know now where this is going to be, because in the middle of those two is 180. We already know now each box represents 4, so 184, 188. So the upper quartile is 188. To get the interquartile range, we do the upper quartile, subtract the lower quartile, and 188 take away 50 is 138. There we go. For that one there, you do need to read that very, very carefully and make sure that you're getting your scale correct. Becky says 50% of the people waited for at least 2 hours. Is Becky correct? Well, 2 hours, obviously our box plot is shown in minutes, so times that by 60, that's 120 minutes. Now where is 120 minutes? 120 minutes is right here, and that line right in the middle of the box is the median, and the median represents where up to 50% of the people or over 50% of the people are. So they are on 120. So is Becky correct? 50% of the people? Yes, as the median is 120 minutes, and that is 2 hours. There we go. And there we go, there is an explanation for the median. We've now got something else. The table gives information about the length of time in minutes some people waited to see a doctor at the same hospital on Tuesday. Becky was asked to compare the distribution of the length of times people waited on Monday with the distribution of the length of times people waited on Tuesday. She wrote, people had to wait longer on Tuesday than on Monday. Give one reason why Becky may be wrong. Well, let's have a look. Let's just see anything. So she says people had to wait longer on Tuesday than on Monday. Okay, and this is Tuesday. Okay, so let's just make sure we get a good comparison here. So let's have a look at the median. So the median on Tuesday was 100. The median on Monday was 120. So let's just have a look. So the median was lower on Tuesday than it was on Monday. How does that support the statement? People had to wait longer on Tuesday than on Monday. Well, that doesn't really add up with the median. So I would say, we'll give one reason why she may be wrong. Well, let's just say the median is lower on Tuesday. There you go. So there are possibly other things that you could look at there, but I think that's the most obvious in terms of just looking at the median. Are there any more parts to that? Nope, so we're done. There we go. So not too awful there. Okay, on to some surds. So definitely a non-calculator question, obviously, with surds. So let's have a look at how we approach this. So it gives us some brackets, and it says it can be written in the form a plus root 10. Now I like surd questions like this where it gives you a hint as to what number is going to go under the square root. So we've got a 10 there. So if I expand these brackets, remembering that we just multiply surds like normal numbers as long as they're both under the square root, 5 times 8 is 40. So that would be root 40. Plus 5 times 18. 5 times 18 is 90. So that would be plus root 90. There you go, and just doing some times tables. Nice and easy. Simplifying the surds is a little trickier because you do have to know how to simplify them, but root 40 is the same as root 4 times root 10, and root 90 is root 9 times root 10. And again, I've got those 10s so quickly there because it says in the question it has to be a root 10. So the square root of 4 is 2, so this would be 2 root 10, and the square root of 9 is 3, so that would be 3 root 10. Now the number under the square root is the same, so these can be added together. That would make 5 lots of root 10. So the letter A is in front of the root 10. A is going to be equal to 5. And there you go. Really nice sort of surd calculation there, where we just had a bit of everything, bit of expanding brackets and simplifying. Okay, so this diagram shows a solid shape, and the shape is a cone on top of a hemisphere. The height of the cone is 10. The base of the cone has a diameter of 6. The hemisphere has a diameter of 6. Okay, that's all written for us on the diagram. The total volume of the shape is k pi centimetre cubed, where k is an integer. Work out the value of k. Now, not every single time we're working in terms of pi it's going to be non-calculator, but it tends to be a non-calculator topic because of the only real reason we'd use terms of pi is if we were doing it without a calculator. So let's assume this is a non-calculator question, but of course it could be a calculator variation of this where it's asking you to work out the volume of it, I don't know, to 3 significant figures or something like that. So we'll approach this in a non-calculator way. So to start off, we will find the volume of the cone. Okay, you can do either, but let's start with the volume of the cone. The formula is given to you, so it's 1/3 pi r squared h. Now, don't get the diameter confused with the radius, always draw that in. So the radius is half of 6, so that's 3. And if we plug that into the formula, that's going to be 1/3 times pi times r squared, so 3 squared. I'll write 3 squared rather than 9, times the height, which is 10. So that is 1/3 times pi times 9 times 10. Up to you which way you work this out. You could do 1/3 times 9 or 9 times 10. You can do it in any order. I'm going to do the 9 times 10. So 1/3 times pi times 90. And then 1/3 times 90 is just 1/3 of 90. So 1/3 of 90 is 30. So that'd be 30 pi. So the volume of the cone is 30 pi. The next bit, we need to get the volume of the hemisphere. So the formula is given to us, 4/3 pi r cubed. So that'd be 4/3 times pi times 3 cubed, and it is a hemisphere. So when it is a hemisphere, we also need to multiply by a half. Now what I like to do, if we get rid of this, I like to multiply the half by the 4/3 to start with, rather than sort of overcomplicating loads of fractions in there. So that can be a really nice way of doing it, times the top, times the bottom. A half, I'm going to do this up here, look, a half times 4/3 is 4/6, and 4/6 is just 2/3, and it makes quite logical sense that 2/3 is half of 4/3. So let's just change that, so that would be 2/3 times pi multiplied by 3 cubed, 3 times 3 is 9, times 3 again is 27. Okay, still doesn't look overly nice, but 2/3 of 27 isn't too bad. You can work out 1/3 of 27, which would be 9, and 2/3 would be 18. There we go, so 2/3 times 27 is 18 times pi, so 18 pi for the volume of the hemisphere. Now we just need to add those two together. So we have the volume of the cone, 30 pi, the volume of the hemisphere, 18 pi, add them together, that is 48 pi. Now it only wants to know the value of k. K is the number in front of pi, so the number in front of pi is 48, so k is equal to 48. And there we go. So we go, a little bit of sort of compound volume there with cones and spheres. On to the next one. Okay, so for this question we have angles in parallel lines, and just looking at it straight away, we've got some algebra involved. We've got an angle here which is just x and an angle here which is w. So we better read the question. It says in the diagram, ABC and DEFG are parallel lines. Angle AB is x and EB equals EF, which we can see via these lines here that we have an isosceles triangle involved. It then says show that W is equal to 90 plus half x and give a reason for each stage you're working. So we do have quite a lot to do here, so let's have a look. So when we have parallel lines, straight away I look for any alternate or corresponding angles. And I know there are different ways of approaching these questions all the time, but that's just how I do my first step. So I can see that that x hooks in an alternate angle down here. So that right there would also be x. Now let's not forget this question does say give a reason for each stage you're working. Now again, you can write out sort of mathematically written angle explanations. You can write BEF for that, so you could put down here BEF is equal to x, and the reason alternate angles are equal. Now you don't necessarily have to do it this way. It's a very good way of doing it, but you can just point an arrow to that and write that explanation right there, and that's absolutely fine. I prefer to do that especially when we're going through it on a video, because it means I don't have to keep scrolling up and down. But there we go, maybe as I've started, let's do it a slightly different way for this one. Now the next angles that we can find is related to the fact that it's an isosceles triangle, because we know that base angles are equal. Not forgetting, this isosceles triangle has been rotated on its side. If it was stood up, if we kind of imagine it, these are the base angles. So this has been pushed onto its side. To work out the base angles in an isosceles, you take away the top angle from 180, so 180 minus x, and you would divide it by 2, as it's obviously split between the two. Now we can divide both of those by 2. 180 divided by 2 is 90, and 1x divided by 2 is half x, so minus a half x. You could write that as 0.5x, but as in the question it wants us to have like a half here, I may as well leave it in fractional form. So there we go, that is the size of one of those angles. Let's label that on the diagram, and then we need to write our reason for that as well. I'll only label it there, it is the same as this one too, but I just need to label the 1 because now I can get to W. So that angle there, let's have a look. You can describe it in one of two ways. I could say EFB, badly drawn line there, or BFE. Either one's absolutely fine. So EFB, let's just write this down here. EFB is equal to 90 minus a half x, and that's because base angles in an isosceles are equal. There we go. Are equal. Now it looks like we've just got one more step. So let's do this in another colour. This final step here, these angles are on a straight line. So that angle and W, which is the one that we're looking for, are on a straight line. We know angles on a straight line add up to 180. So I'd need to do 180, take away the angle just next to it. And the angle just next to it is written in two parts. You've got 90 and the minus half x. So when that occurs, always put it into a bracket. 90 minus a half x. Now the reason for that is because we're taking away 90 and we are taking away negative a half x. And if you don't put it in a bracket, you might forget that you've got to take away both from 180. And something happens when we do that. 180 take away 90, that's easy enough, that's 90. But then take away as well negative a half x. When you take away a negative, it becomes a positive. So it becomes 90 plus half x. And that's good because that is what we're looking for in the question, so that's okay. But let's write this down then. So that angle was BFG. There we go, so BFG is equal to 90 plus a half x, and the reason for that was angles on a straight line add up to 180 degrees. There we go. And again, if add up to, let's write this down first, add up to 180 degrees. If you don't like writing it in this form, it's absolutely fine to put these reasons over by your working that you've labelled on the diagram and just make sure it's really nice and clear. Okay, absolutely fine to label them up there though, but there we go, we've written it ever so slightly differently. So we've shown that W is equal to 90 plus half x, and we've given all of our reasons. So there we go, some angles in parallel lines, while also involving some algebra. On to our next question. Okay, so we've got some pretty tough ones coming up here. So this question, we have got completing the square with coefficients of x squared bigger than 1. Now if you know how to complete the square, this isn't really too much of a step up because you just have to divide everything by 2 to start with. But you can get some pretty nasty numbers involved, particularly if any of those numbers don't divide by 2 perfectly. And we can already see there's a 35 in here, so we are going to get some decimals involved. So if we take the 2 out to start with, and remember the 2 doesn't disappear, we're just factorising 2 out. So you get 2 lots of x squared plus 8x plus, and you can either write that as 35 over 2 or you could write it as 17.5. Completely up to you. Now I can actually go about completing the square just for what's inside the bracket. So at the moment I'm just going to ignore the 2 and just complete the square. So that'd be x plus 4 in brackets squared. You have to think, what's this going to be when you expand that double bracket? Remember, you get x squared plus 4x plus, and this is the number we're looking for, 16. You might want to keep the symbol with that as well, plus 16. Now we don't want plus 16, we want plus 17.5. So after expanding that bracket, to make it the same as the one above, we would have to add in an extra 1.5. So we need to plus 1.5 at the end of that. And here's where we bring back in the 2. So all of that has to get multiplied by 2. So what you can do is you can introduce a bigger bracket or a squared bracket, it doesn't really matter, and we put 2 on the outside of it all. Then we can multiply the 2 back in. So the brackets will just be multiplied by 2, so you'll have 2 lots of x plus 4 squared, and the 1.5 at the end would also be multiplied by 2, which would make plus 3. And there we go, it's now in the form that it was looking for. So our final answer would be 2 lots of x plus 4 squared and 2 lots of 1.5, which is plus 3. And if you were to expand that double bracket, x plus 4 squared, times it by 2 and add 3, you would get that original one, and it sometimes is worth checking it out. If I did it very, very quickly, x plus 4 in brackets squared would be x squared plus 8x plus 16. If you multiplied that by 2, you would get 2x squared plus 16x plus 32, and then you have the plus 3 at the end, and that would be 2x squared plus 16x plus 35, and it does match what was in the question. So we know we've done it correctly. Of course, if you're confident with the process, you don't need to do that. If you are confident with the process, even if you're not confident with the process, doing all of that in reverse is probably going to be pretty tricky as well. So it's a good step to be able to do, but if you're confident, then you probably don't need it. It says, hence or otherwise, write down the coordinates of the turning point of the graph with that equation. It is the same equation that we had just up there. So obviously we've got the y equals because now they're relating it to a graph. Now the nice thing about this, it doesn't matter that 2's in front of the bracket. We still read the numbers the same as we would for normal completing the square. And that is that the x coordinate is the number in the brackets, but you flip the sign. So x is -4. And the y coordinate is just this number at the end, and you don't have to change the sign for that, so that's just 3. So the turning point, -4 and 3, and there we go. There is the coordinates of our turning point by completing the square. Okay, on to question 19. So here we've got the sine graph, and it says on the grid, sketch the graph of y equals sine x minus 2 for, and then it says for x values between -180 and 180. So when you have a graph transformation, you either have a change going on inside or outside the bracket. Now this is outside the bracket because we haven't had any brackets been put in there. You would have maybe, if it wanted to sort of change the x coordinate, it would be written like this, sine of, and in brackets, x minus 2, like that degrees. And that would actually change the x coordinates, but this is outside of a bracket, there's no brackets in there, so it's going to change the y coordinates, which is good. When it changes the y coordinates, it does what we'd expect. And -2, you would expect to move it down. Obviously up and down the y-axis, -2 goes down, +2 would go up. So all we need to do is move this graph down by 2 and draw it in nice and neat. So find any whole number coordinates. I'm going to start with the origin, move them down. There's another quite nice one here on 90 where it's 1, so move that down to -1. I'm going to have to count that carefully. 1, 2, 3, 4, 5, just there. You got this one on the axes again, so that's just here. We've got another one just there on -1, that's going to go down to -3. I'm going to have to count that carefully. 1, 2, 3, 4, 5, just there. And then you've got this one here on 180, that goes down by 2 to the -2, there we go, and then we just need to draw that in, and again it's a nice smooth curve, and there we go. And you don't have to stress too much about getting every single point on the curve perfect, but the whole number coordinates, they're the ones that we need to make sure we're getting absolutely perfect, and then obviously making it look pretty much the same. So there we go, 2 marks, that's a graph transformation and a trigonometric graph kind of thrown together into one question. So this question says, here is a right-angled triangle. All the measurements are in centimetres and the area of the triangle is 27.5 centimetres squared. Work out the length of the shortest side of the triangle, and you must show all of your working. So first things first, we've obviously got some algebra, so we're looking at forming and solving equations. It talks about the area of a triangle and it gives us the area. So what we can do is we can actually go about writing the area of this triangle in terms of algebra. Now if we imagine, obviously if we flip this round, this was the base and this was the height, or of course you could do it the other way around, although it doesn't overly matter which one we pick. Just the fact that there's a right angle between them, we know it's a perpendicular height, whichever way it's sort of oriented. So if we write this down here, because we're going to need a fair bit of space for this, we've got the base times the height. Now as there are 2 pieces in each of that expression there, we'll put those in brackets. So we've got x minus 2 multiplied by x plus 4. Now straight away that gives us a double bracket. You know that for the area of a triangle you have to divide it by 2 or multiply it by a half, whichever way you want to look at it. I'm going to put over 2. So all of that divided by 2, and it tells us that the area is 27.5, so we know that that is going to equal 27.5. Now we just need to solve this. We just need to find the value of x and then sub that back in to find one of the shorter sides, which looking at it, look, it's not going to be x plus 4 because whatever x is, if we take away 2 from it, it's going to be shorter than if we add 4 to it. So we just need to find the length of that side. So in order to solve this, look, we need to first get rid of this divide by 2. So times both sides by 2, and at the same time we could expand this bracket. Okay, you can do it in 2 steps or 1 step, it's up to you, but we need to expand that bracket. So x times x is x squared, x times 4 plus 4x, and then negative 2 times x minus 2x, and negative 2 times positive 4 is negative 8. So the expression that we've got there is x squared plus 4 and minus 2 makes plus 2x and then minus 8. And just double check these stages as you do them, because if you make a mistake here, it's going to be a real pain to go all the way back and have to do it all again. So we're happy it's plus 4 and minus 2, 4 take away 2 is positive 2, and minus 8 at the end because it is a negative times a positive. Right, I'm happy with all of it. So we're going to have x squared plus 2x minus 8, and don't forget we're multiplying everything by 2, so this 2 on the bottom is going to disappear, and on the left there, on the right there, we are going to have double 27.5. 20 doubled is 40, 7.5 doubled is 15, so that's going to equal 55. So we have a quadratic equation to solve. When we want to solve a quadratic equation, it has to equal 0. So we need to subtract 55 from both sides. Once we've done that, it'll equal 0, and we can then go about factorising it and solving it. So negative 8 take away 55 is equal to negative 63. So we have x squared plus 2x minus 63, and that's now equal to 0. That's going to be quite a nice one, hopefully, because we can hopefully factorise this into double brackets. Otherwise, we would have to use the quadratic formula. But of course, you can use the quadratic formula if it's a calculator question at any point. You don't actually have to be able to factorise after paper 1, although it should save you some time. So 63, that is 7 times 9. Now, even if there are other versions, that's the first one I've spotted, and I've also spotted that that pair of numbers I can make positive 2 with. I can have plus 9 and minus 7. One has to be positive, one has to be negative, because they multiply to make negative 63. So I'm happy with that. Of course, if I didn't spot that straight away, I'd write down some more factor pairs like 3 and 21 and 1 and 63, or whatever it is, however many there are, in order to find the pair that I need. But I've got the pair straight away. Now you flip the signs, so x can either be negative 9 or x can be positive 7. Now, obviously, x cannot be a negative number based on these expressions. It's not always the case, but it usually is the case. For example, you could have an expression that was something like 2 minus x or something like that. And therefore, negative 9 would be 2 take away negative 9, it'd be 11. So you could have a negative value of x, you just need to look at the expression. This expression though, x minus 2 and x plus 4, if you had negative 9 in either of those, the length of that base there would be negative 11, which is impossible, and the height would be negative 9, add 4 would be negative as well. So we can't have negative 9. So that solution there, we may as well already cancel. So x has to be plus 7. We don't need to write a description as to why it's plus 7, we just need to know that it's only 7 that we're going to use. So if we sub that into this length here, 7 take away 2 would be equal to 5, which is the shortest length. And obviously just to show that to yourself, look, you could put 7 in here, but 7 plus 4 is equal to 11. So it's going to be 5, that's the shortest length. And we've shown all our working, so we'll say 5 centimetres. So the question follows some logical progression here. You might just want to write that down here. 7 take away 2 equals 5. But there you go, don't necessarily need to. So there you go, that is forming and solving an equation with a quadratic. And just as a side note, obviously at this point here, we could have subbed it into the quadratic formula. So A would be 1, B would be 2, and C would be negative 63. We'd then put that in, so minus B, minus 2, plus and minus the square root of b squared, so 2 squared, minus 4ac, 4 times 1 times negative 63, and that's all over 2a, which is 2 times 1. You put that into your calculator once with the plus, once with the minus, and it's going to give you negative 9 and positive 7. But again, you don't have to do that. That's just a side note that you could use that process if you prefer. Okay, but either way, we get the answer 5. On to our next question. Okay, so for this question, we have some 3D trigonometry. So it says here we have a pyramid with a base ABC. CD is perpendicular to CA and CB, and we can see some right angles drawn over there. We have angle CBD is 34, that's given to us. We've got the 45 and the 60, they're all on the diagram. B to C is 20, also on the diagram. Calculate the size of the angle between the line AD and the plane ABC. Now the line AD is here, and the plane is this base on the bottom, so I could colour the whole thing in, but we're just looking at the angle between those. And that angle is right here, on that right angle triangle at the back ADC. So in order to find that angle, we need at least 2 lengths on that right angle triangle. That way we can use SOHCAHTOA. At the moment, we've got no lengths on that triangle. So we need to have a look on this diagram and think about how we're going to find at least 2 of those lengths. Now the first one that stands out is this right angle triangle on the side of the shape, because I can use this one with an angle and a length to find this length here. So I'm going to start with that one. Now if we label that up, and you can draw it to the side if it helps, you've got 34, 20, and we want this length here. So if we label that up, this is the opposite, this is the adjacent. So to work out the opposite, we're going to be using tan, as we have O and A. So if we use tan to find the opposite, we do a multiplication. So tan 34 multiplied by the adjacent 20. Remembering obviously we're crossing off the O there. So we type that into the calculator. So tan 34 times 20, and that gives us a length 13.49017. It says it wants our answer to 1 decimal place, so we can probably get away with not writing 5 decimal places, but just to keep it really accurate, that's what I'm going to do. So I'll label that up here, 13.49017. There we go, that is the first length found. We now just need to find another one. So can we get one on the base? Well, on the base we don't have any angles for the full base, we just have one length, B to C. So let's have a look at this triangle instead. So we've got a triangle here, and that gives us 2 angles, but no lengths. Now we could actually find this third angle here, because 45 and 60. So for this angle here, we do 180, take away, 45 add 60 is 105, so that angle there is 75. We may or may not need that, but it's going to be there just in case we do. So can we find any other lengths on that triangle? Because if we did, we could use the sine rule. Let's have a look. Let's just draw this triangle. There we go. We've got 75, 45, and 60. Now we want the length of A to D, because that'd be over on this triangle, this one here. So if we put that over here, look, if we had one other length, we could use the sine rule, because we'd have pairs of opposites. So let's see if we can find one of these other lengths. Let's swap to a different colour. Let's see if we can find this one, as we have a right angled triangle there. Let's get rid of that X. So to find that one, we can definitely do that, because we have a right angled triangle, and we've got an angle in it, and we've got both the lengths. So we could either use Pythagoras or SOHCAHTOA, because we have the length 20, the angle 34, and we do have the height of that triangle, although I prefer to use SOHCAHTOA, so I'm just going to use SOHCAHTOA, but you could use Pythagoras at this point, absolutely fine. So this is going to be the hypotenuse. We don't have the opposite, this is the adjacent. So for this one, for this particular triangle, I'll be using cos, so CAH, and we are finding the hypotenuse. To find the hypotenuse, cross that off, and it's A divided by C, which is 20 divided by cos 34. Type that in on your calculator, 20 over cos 34, and that is equal to 24.12435. So there we go, that length we now have. And I can label that up here. 24, it's a bit awkward to label. I have to label it like this so I know which one it is. 24.12435. And if we put that onto our diagram over here, 24.12435, we can now use the sine rule, because we have this angle opposite this side. So if I want to use the sine rule, okay, and we'll go with that, let's bring this all down so we've got a little bit more space to work from. There we go, let's bring that down to here. So now I can use the sine rule. Okay, once I've got this side here, which is what we're now looking for, I will then be able to use SOHCAHTOA on the final triangle. So as you can see, an awful lot of steps here, 5 marker on 3D trigonometry. So the sine rule, A over sine A is equal to B over sine B. So let's label these sides up. I like to call A the side that I'm looking for. So let's call that A, opposite that big A, and then B and big B. So we have x over sine 60 is equal to 24.12435 all over sine 75. One step to rearrange that, you just need to multiply sine 60 up to here. So it'll be 24.12435 sine 60, and then this will be gone, times that over. So x will equal, and let's just type it straight in to avoid writing down loads here, 24.12435 on the top of the fraction sine 60, and on the bottom sine 75. Press equals, and we have x is equal to 21.6293 and then a few zeros. So there we go, we now have that length there, and we can almost find the final triangle. So that's 21.6293. So 21.6293. Final step now, we can actually find the size of that angle. I'm going to do it up here because there's so many numbers everywhere. It's just easier to do it next to the question. So on that triangle at the back, we're looking at A, D, C. This length is 21.6293. We want the size of this angle, and we know the height is 13.49017. So let's get rid of a little bit of this working out, so we've got a bit of space. Now, labelling this triangle up, we have got the opposite and we've got the hypotenuse, so we're going to be using sine. This time we are looking for the angle. When you're looking for the angle, we cover up the letter, and it's O over H. When we're finding the angle as well, we have to press shift sign, so it's sine minus 1. The O is 13.49017, and the H is 21.6293. So let's type that in. So shift sign, fraction, on the top 13.49017, and on the bottom 21.6293. Double check you've typed it all in correctly. There we go, and press equals once you're happy with it, and you will get your answer. My answer has come out as 38.5867. Some more decimals after that, but I'm not going to carry on because I know it only wants it to one decimal place, so chop it after the 5, and that would be 38.6, and it was an angle, so degrees. And there we go, there is your final answer, 38.6. So a lot of working out for that one, but there you go, 3D trigonometry questions can just be very difficult. I would say this is one of the hardest in terms of this topic, but there you go, they can be very difficult. You've got to be really, really fluent with your SOHCAHTOA and your sine and cosine rule, although we only needed the sine rule for this one. Okay, on to our next question. We're getting pretty close to the end. Okay, so this question, it says S is a geometric sequence. Given that root x minus 1, 1, and root x plus 1 are the first three terms of S, find the value of x, and you must show all your working. Okay, so if we think about a really basic geometric sequence, something like 2, and let's, I don't know, multiply it by 3. 2 times 3 would be 6, and then times it by 3 again, and that'd be 18. To find the common difference of 3 in a basic sequence, you would take the bigger divided by the smaller. So 18 divided by 6, or you could do 6 divided by 2. But the important thing is they have to be the same. And they are. 6 divided by 2 is 3, and 18 divided by 6 is 3. So whenever you do the term after divided by the term before, they will always be equal in a geometric sequence. And we can apply that logic to this question. So the term after, 1, divided by the term before, or 1 over root x minus 1, has to be equal to the term after, root x plus 1, divided by the term before, 1. So root x plus 1 divided by 1. So let's get rid of this, because this was just numbers that I made up to sort of see why, to show a bit easier why I was doing what I'm doing here. But now we have an equation that we can solve in order to find x. Now for starters, what I wouldn't do is I wouldn't write that second one being over 1, so we'll get rid of that. So 1 over root x minus 1 is equal to root x plus 1. Now to solve this, we want to first get rid of the fractions. So times both sides by root x minus 1 and times the right by root x minus 1. Now we're going to want to put these into brackets as they are going to go next to one another. So 1 is equal to what's already on the right, root x plus 1, multiplied by root x minus 1. If we expand that bracket, noticing also it's a difference of 2 squares, you get 1 is equal to root x times root x, which is x. Root x times minus 1 is minus root x, but then you've got plus 1 times root x, which is plus 1 root x. So they cancel each other out. But you've got 1 times minus 1, which is minus 1. So you end up with a really nice equation here. 1 is equal to x minus 1. Add 1 to both sides, you get 2 is equal to x. Or you could write that out as x is equal to 2. So that was part A, x is equal to 2. And there we go, there is your final answer. Obviously take your time with the expansions there. For part B, it says show that the fifth term of s is 7 plus 5 root 2. Now we had the common difference written in 2 different expressions up here. You've got either 1 over root x minus 1 or this one on the right, which actually didn't end up being that bad. It's just root x plus 1. So our common difference is root x plus 1. You can use either one of those. But now we know the value of x. We know that that is root x plus, or root 2 plus 1. So you might want to write down the common difference. There you go, is root 2 plus 1. And that's what we multiply each term by to get the next one. So the current term that we're on is root 2 plus 1. Okay, so we're just going to have to multiply it by itself. So for the fourth term, it would be the current term, root 2 plus 1, multiplied by the common difference, which is root 2 plus 1. So we have a double bracket to expand. Root 2 times root 2 is 2, root 2 times 1 plus root 2, 1 times root 2 plus another root 2, and 1 times 1 is 1. And if we simplify that, our fourth term is 3 plus 2 root 2. That's our fourth term. We want to find the fifth term, and we have to show that, so we've actually got to work it out. So the fifth term will be our current term, 3 plus 2 root 2, multiplied by our common difference, root 2 plus 1. So we've got another double bracket. 3 times root 2 is 3 root 2. 3 times 1 is 3. 2 root 2 times 2 is 2 root 4, or 2 times 2, which is 4. And 2 root 2 times 1, which is 2 root 2. Combine the surds there, you have 3 root 2 and 2 root 2, which is 5 root 2, and 3 plus 4, which is 7. Now that's just in a slightly different order to what it's asked, so we'll swap those over. 7 plus 5 root 2, that's our fifth term, and we've shown all of our working out there. We just had to do some surd brackets, so 2 lots of double brackets. And there we go, there is our geometric sequence. There you go, quite a lot of work there, quite a unique question. But on to what I believe is our final question. Okay, so we have a quadratic simultaneous equation. And just looking at it straight away, we've got quite a nasty one because we've got a 2x squared in one of those equations. That's not really going to throw us at all, it just means it's probably best for us to rearrange the second equation for x, which it looks like it's easier to anyway, and when we've expanded our double bracket, we'll have to times it by 2. So this question here, you need to be pretty good at quadratic simultaneous equations, but let's rearrange this second equation as x is equal to 1 minus 2y. Now we can put a bracket around this and put it in place of the x in this equation here. And let's just write that out. So that would say 2 lots of 1 minus 2y squared minus y squared, and that's equal to 17. Now you can do this in as many or as shorter steps as you like. I'll try and do a minimal amount of steps with enough that it doesn't sort of confuse this whole question. So in order to do this, we want this to be a double bracket. So we've got 2 lots of 1 minus 2y and 1 minus 2y. Minus y squared is equal to 17. Now I've got to expand that double bracket. When I expand double brackets, and particularly when I've got a lot of steps like this, I do like to minimise the amount of writing I do. So let's just try and expand it without writing every step down, although of course you need to write every step down if you're not comfortable with this next step. I'm going to do a slightly different order to what I normally do as well, because I want the y squared to go first, just so it looks like a normal quadratic. So I'm going to do negative 2y times negative 2y, which is positive 4y squared. Then I'm going to do both middle pieces, so negative 2y times 1 is minus 2y, and 1 times the minus 2y is another minus 2y. Minus 2y minus 2y is minus 4y. Then I've got the 1 times the 1, which is just plus 1. And there it is expanded. Now you can expand that to the side, tidy it all up, put it into this same order, but I just like to do it in one go. Now we just need to multiply it by 2. So 2 lots of 4y squared is 8y squared, 2 lots of negative 4y, negative 8y, and 2 lots of 1 is 2. Then you've got the minus y squared afterwards, and it all equals 17. We've got 2 steps here. We want to join up those y squareds. It seems a bit pointless to write that out in one step, so let's also minus the 17 in the same step, just to reduce the amount of lines we're writing here. So 8y squared minus 1y squared is 7y squared. Minus 8y, that's not changing. And 2 minus 17 is minus 15. It now equals 0, and we can now solve it. You can either put that into the quadratic formula or attempt to factorise. To be fair, time dependent, I'd always try the factorising first, although if it was on a calculator paper, I might just throw it into the quadratic formula just so I don't waste any time. So the factors of 15, we could have 1 and 15 or 3 and 5. Now because we've got a 7 in one of the brackets, I'm thinking it's probably going to be the 1 and 15, but let's try it out. So if the 1 was multiplied by 7, then you'd have 7 and 15, and you'd get negative 8. So we want the 1 to be multiplied by 7, we want the 15 over here. We're trying to make negative 8, so I want plus 7 minus 15, yep, so plus 1 minus 15. There we go, that works, just double check it. 7 times the 1, 7y times 1 would be plus 7y, minus 15y would give us minus 8y, yes, so it works. So here y would be positive 15 over 7, and here y would equal negative 1. Again, you could put that into the quadratic formula, and it would obviously give you those solutions. Now we've got the values of y, we want the values of x. So let's use this equation up here. X is equal to 1 minus 2y. So let's just put this to the side. X is equal to 1 minus 2y. So let's do the easy one. When y is equal to negative 1, x will equal 1 minus 2 lots of negative 1, which is negative 2. So 1 take away negative 2. So x will equal 3. As we know, taking away a negative just becomes a positive. So when y is negative 1, x is equal to 3. That's going to be one of our answers. For the next one, when we'll keep saying x, there we go. When y is equal to 15 over 7, x is going to be equal to 1 take away 2 lots of 15 over 7, so 30 over 7. So x will equal 1, I'm imagining as 7 over 7, so 7 take away 30 would be negative 23, so negative 23 over 7. Again, you can take your time to do that. I've just done 7 over 7, take away 30 over 7, 7 take away 30 is negative 23. So there we go, there are my pairs of answers. So I would say x equals 3, y equals -1. And for the other one, x equals -23/7, y equals 15/7. Oh, there we go, not very nice final step there, but there is our final answer. Okay, I do like it when they put the dotted lines on these questions though that show you where to put x and y, because I always feel like when it's a blank page, which they do quite often in these exams, I just feel like I don't really know where I'm writing my answer. So make sure it's really nice and clear down the bottom. You can always put a box around it if that sort of makes you feel a little bit better at the end. But there we go, that is the end of the paper. A huge amount of topics there, some really, really nice questions. Hopefully you found that useful and helpful. Again, don't forget to sign up to the free trial of Upgrade, and don't forget to drop me a comment, don't forget to like the video, and I'll see you for the next one.